What does the 2 stand for in Amazon EC2? It stands for cloud. Amazon, compute, cloud. There's 2 things that start with C, so there's 2 of them. With a name that straightforward, you can guess that the rest of the names inside of the service are going to be equally as intuitive. Now, Amazon EC2 has hundreds of different instance combinations, instance types that you can choose that run VMs inside of Amazon, inside of AWS to run your workloads. But how do you know which one's the right one to pick? How do you know what they even mean? That's what we're here to solve today. EC2 instance names never made sense to me, so here's the guide that I wanted when I was getting started. Let's understand it together. Let's look at an instance name to see what it's made of generally first. Every instance has a family that it belongs to, which is roughly what it's used for in some sense. It'll have a generation, which is kind of like a release of that version with newer RAM or CPU types or disks. It will have or may not have some capabilities. The capabilities are special things that that instance type can do. Sometimes the capabilities are implied, but other times they're explicit. And finally, every instance type has a size. This ranges everything from micro to metal in how big the actual instance is for you to use the resources available. I'm going to go through all of these components here in the videos just so you can follow along and see what each type means. But if you want a reference infographic or text-based version of this, head over to justingarrison.com. I have it all laid out there. So let's start with the families. There are 6 different types of EC2 families. General purpose is the most general, but there's also compute, memory, storage, HPC, and accelerated. These are all different families of compute, which generally refer to the ratio of memory to CPU, or virtual CPUs. So for every 1 CPU, how much memory is there, but also how much network performance and disk performance is there. Different workloads have different constraints on what they need to consume resources. So if you have something that needs a lot of CPU, you'll look at a compute instance. If you need a lot of memory, there's memory instances. If you don't know, general purpose is a good rounded. If you need something that needs specialized hardware like FPGAs or GPUs, that's where accelerated comes in. These are for your machine learning jobs, your remote workstations with GPUs, training types. These all have additional hardware that is added onto the instance and mounted into the VM so that you can use it as part of your workload. Generally, you probably don't need these unless you know for sure that your workload is going to use that hardware, because they're going to be a little more expensive and may not have the same amount of availability that other instance types will have. Each one of those families is broken up into different types. Some of them have more than others, like a HPC family only has 1 type, HPC. The compute type only has 1, the letter C. The other ones will have different ones just based on what is needed. So each family is roughly going to tell you what type of workload is going to be running on it or what constraints the workload has. If you're using something that is more of like a cluster, like container orchestrator for something like EKS, in that case, you're probably going to want to go with something that's memory optimized, because a lot of web workloads have memory constraints more than they have CPU constraints, because the CPU bursts a lot more. In most large-scale production environments, I would also advise against using something like a T-series, which are burstable CPU. They have a quota that's available to them and they can burst over that quota, but in general, they're not meant for like a steady state CPU usage. It's just for really bursty workloads that lower the price for you, but add inconsistencies in performance. Moving right along to the next step is the generation, and this is numbers 1 through 7, which don't necessarily say 7 is better than 1. It's newer in a lot of sense, but it all depends on when the family was introduced into EC2. So older family types have newer generations. The R7s are brand new, they've been around for a little while. Something with a 1 generation may not necessarily be older or worse performing than with a 3 or 4 generation, but in general, the instance family as it matures gets a higher generation as new CPU models are introduced, new types of RAM, disk storage, that sort of stuff. As performance progresses, generation increases. Almost every generation that's available now is using Nitro. It used to be the case that only new generations were Nitro-based, which was great for performance and some added abilities to mount more volumes, but a lot of the older generations have been retrofitted with Nitro in them as well. So you don't have to worry about which ones have Nitro as much anymore, because all of the old instance types that are available are also getting Nitro cards to be able to have the additional performance and benefits that Nitro brings. Capabilities of each instance type ranges pretty wildly, and so some instances will have multiple letters that denote what type of capabilities they have. Some of them will have no letters, but that doesn't mean they don't have the capabilities. Many of the capabilities have to do with what type of CPU the instance family has. If you get an A, you have an AMD instance type, I is for Intel, and G is for Graviton. 3 different types of CPUs, which are capabilities of those instances. You also have optimizations and better performance. Something like a Z is going to give you turbo CPU frequencies for your Intel CPUs, and something with an N is going to have a higher network throughput. More performance is relative to the instance itself. So an instance with an N capability may not necessarily have faster network than something without it, because that does depend on the family itself. If you're using a storage family instance, that will likely have more network throughput than something in a general purpose, just because using a lot of storage also generally requires a lot of network. And so your network performance on a storage instance will probably still be higher. But if there's an instance family you want to use, or you prefer using certain instance types and you need additional capabilities like local NVMe drives or faster volumes, you can look for ones with those capabilities that will enhance that family type for that type of workload. And finally, the instance type will have a size. Sizes range anywhere from nano for the absolute smallest all the way up to metal for the largest instances. Nano instance types are going to be the absolute smallest. These are less than a CPU, maybe less than a gig of RAM, and are useful for really, really small workloads, single web servers, things of that nature that need to be cheap. On the other end, you're going to get really large instances for metal instance types and 112 extra large. These are the largest instances we have available right now, and these will have dozens of CPUs, hundreds of gigs of RAM, if not terabytes of gigs of RAM. This is for really large workloads, something that has to fit in a single machine, or if you need to utilize that hardware to its fullest for something like an HPC workload. All of the sizes grow incrementally and generally are twice as big as the number of XLs grow twice as large. So a 16XL is going to be twice as big as an 8XL, and that depends on the family. If you're looking at a family with 8 gigs of RAM per one CPU, let's say that's a extra large, and you go up to a 2XL, then you're probably going to get 16 gigs of RAM with 2 CPUs. They grow linearly as the size increases, doubling every time an XL doubles as well. So a 4 to an 8 to a 16 and onwards, you're going to get more and more of the same capacity or relative capacity based on your memory, your storage, and your CPU. Some things don't grow linearly, such as network performance. That's probably going to be fixed based on the CPU. As you add more CPUs, you might get some more network performance, but there is a cap on how much network performance you can have, because network in general comes in stages of something like 1 gig to 10 gig to 40 gig. And then beyond that, you're looking at something in the 100 gig range, just because network is capped that way. CPU and memory is a little bit more flexible in the way that's allocated, and so you can more easily grow those as the instance types grows in size. So that's it for looking at these instance names. Just remember that each instance name is made up of 4 major components. One of those components is optional. The one you're looking at most is typically the family, and you can look into general purpose CPU and memory first for the types of workloads you're running, and then pick which type of instance you want within that family. Beyond that, you're looking at capabilities of CPU type or performance in certain areas such as volumes or network, and then a size for just generally how much you want to fit on that instance. If you're sharing this between workloads, you might need a larger instance size. As you grow larger in instance sizes, typically your network performance is going to increase. The same way as you grow larger in disk sizes, you're going to get more I/O. So if you pick a 500 gig EBS volume, you'll get a certain number of throughputs versus, say, a 1 terabyte volume. There are different volumes that you can mount, GP2, GP3, and I/O, but let's not get into that right now because that just adds more to what you need for your workload. So just looking at the instance families themselves, you'll just want to look at what the limits are for maybe how many volumes they can mount. I hope you found this helpful. Go ahead and check out the infographic and blog post as well. It's down in the show notes because it's something that I frequently forget and often need to refer to. I also have a command line utility called the EC2 instance selector that's linked in the blog post and available in the show notes. And it's a command line way to pick what type of instance you want. Let's say you're looking for something with 8 cores and 100 gigs of RAM. It'll tell you what instance fits that for your accounts in the region and what service types you want. So check out that utility, which is a great way to narrow down the instances available to find the one you're looking for. So thanks so much for watching. Good luck with picking out those instance types for your workloads, and we'll see you next time.